In the first tutorial, we are designing n dipole antenna in 2D axis, which is x and y, and the level of the ground is 0. Now, today in this session, we are designing a n dipole antenna above the ground at any height, and we are trying to see the radiation pattern and the geometry and the value of the source and parameters with a frequency at 300 MHz in free space. So at first you have to understand some of the parameters with their meaningful comment. Now you can see that here the tutorial indicates the editor window. Suppose we consider it as a value of the antenna, which is designed according to this parameter. Today we will discuss about antenna which is really work in this parameter, and after designing we are try to understand the value consideration of the antenna radiation pattern or parameter. So at first you have to see some comments or indications which is noted in the editor window. Here you can see the CM, CE, SY, GW, GE, LD, EX, FR and EN. If you closely look at the next window or next download of this editor pad, you can see there is a meaningful abbreviation of CM. CM indicates the comment, starts a comment, then when it the time to see, which means the end of comment. SOM is the symbol or variable, declaration of symbol, which we can set any type of value according to our perspective range. And GW, which is stands for geometry of wire, and the value which is seen here 190 minus length division to 00 length division to 0.00, then 0.0001, and the first value of this portion geometry of wire indicates the number of tag, and the second 9 which indicates the number of segmentation, and then this first 0 of this line row which indicates the value of x-axis, which is indicates the x1, then the value minus length per division to length divided by 2, which indicates the value in y-axis in negative side, and then the next 0 indicates the value of z1, which indicates the height is 0 of the length. It is in ground, indicates the antenna is designed in ground. Then the 0 indicates the x2, which indicates the value of the direction of x-axis in opponent size of x1 is 0. Then the value indicates a length divided by 2, which indicates the value in y-axis in positive direction is length divided by 2, and the 0 which indicates the value of z2, that means the other side of the z-axis is 0, and the final 0.0001, which indicates the radius of the wire which is used to design this antenna, and the GE0, which stands for geometry end of geometry, which and 0 means the which 0 indicates the geometry window or the portion of geometric work is done at this section. There is no value entered in the geometry. In the next section there is LA, which stands for loads. Here you can see the 5, which indicates there is a voltage source. 5 indicates the voltage source, and 1, which stands for the real part of this voltage source. You can see here the source in the source section, when the value in the section of this load section, you can see the type, which indicates the wire, and which indicates the wire, and the 1, which is the number of tag, and the 00 is defines for the first segment is 0 and the last segment is 0, and the conductor is conductive, which indicates the 5.8001 into 10 to the power 7. The excitation, which stands for the voltage source, EX stands for excitation, which is according to the voltage source. In this you can see that the first 0 indicates the source of this antenna in the central wire of center of the wire is voltage source, and the 1 stands for the number of tag, and the segmentation, which indicates the middle side of the middle side of the wire is connected in with the source. You can see the geometry of wire. The segmentation part is 9, which is the total segment of this wire, and the excitation of voltage source, the value of segmentation is 5, which indicates the value which indicates the wire the central wire, the wire center of the wire is connected with the voltage source. The feeding system is in one direction, and the feed is at the center point. Then the 0, which indicates the option. The option must be in 0. Then the 1, which is the real part of the voltage source. If you consider the voltage source 1 plus 0 is there, then 1 is the real part and 0 is the imaginary part. So we are almost taking all the time. The real part is 1 and the imaginary part is 0, and by default they can take the voltage magnitude and phase 1 and 0. You can change it, but it already happens when you fulfill this voltage real part with 1, then the phase part is already takes this value in by default. This is the frequency section where the 0 1 0 0 300, where the 0 can indicate is indicating the linear frequency sweep, and the 1, which is indicates the 1 frequency step, is 4 cents, and then the 00 is indicates the field, the 2 empty fields. Then the 300 indicates the value of frequency of 300 megahertz, which the value of frequency at 300 megahertz, the antenna can generate the radiation and transmitter receive the frequency. The final 0, which gives the frequency step width of null megahertz, and finally the end of NEC file. You can understand very clearly when you see this part, and this part indicates every part of this motion and the comments. You can see when you are taking at the time of frequency selecting, that is free space, perfect ground, real ground with their response. You can see when the value is given in the geometry information, which stands for, with the abbreviation of GE, then the 0, when the value is given in 0, that means no ground and it's in free space. And when it's -1 or 1, which represent a ground, but the details must be entered in the separate ground card, which stands for GN. When we see, there is the LD section, which is loading of the segment, that's the indication. So when at the time of starting a design, they are taking the value according to their indication, and the value in the seeing in the notepad or NEC input file. We are designing this as their indication. So at first you have to put the value in the symbol or variable part, which can help us to change the value at any time of the length section. So when we go to the symbol section, we define length L equal to, according to them we are taking the value 0.4836, and you can add a comment. It's not mandatory, but to understand anything clearly or the further approach, you can easily visualize the thing which is indicate this symbol. So if you want to add a comment, then you can type LEN of the antenna wire. It's not a mandatory portion, but you can fulfill it as your visualization. Now we are you can see below the window here, we are taking the symbol of 0.4836, and the geometry section GW, geometry of wire, which is type of wire, and the tag number is 1, means first wire, and the segmentation is 9, and the X1, which is 0, and when the Y1 is minus L divided by 2, and Z1 is 0, X1 is 0, then the Y2 is L divided by 2. And Z2 is 0, and the radius they are taking 0.0001. Then after completing this session, there is a command GE is 0, end of geometry, which is 0. Then it means that there is no more wire or no more segments to designing this parameter. Now we are in load section. Load section indicates the 5.1.005.8001 is 7. Now if you see the load section, which indicates the 5, the LD5 used in conductivity of wire and antenna wire. That means it's not the value which must include in this section. It indicates the conductivity of the antenna wire. So when you when you see this value in the editor window, then you have to understand that value is not must to put in these full boxes. You just understand there is conductivity of wire antenna. Then the wire, the one which indicates the number of wire, and 00 indicates the two empty fields. After the seeing the value 5.80017, this is the conductivity. This means the conductivity of copper wire in Mohs, which is the inverse of resistance. So in the time of fulfill this value, this is the wire conductor which indicates the 5, and the 1 which is the tag number or word number, and the field which first segment is 0 and the last segment is 0, and the last 5.800 is to the power 7, which means the conductivity of copper wire. That means you have to take the copper wire to design in this parameter, and to see the radiation pattern according to this. So you have to select the copper. Then you have to design the excitation segment, which includes the voltage source. So here you have to put the value in voltage source, which indicates this first 0, which indicates the voltage source should be taken to fit this antenna. Then the tag number, which is 1, and the segment, which is 5, which is the almost a half of the geometry segment. In geometry segment we take the segment as 9, and the half of the segment is 4.5, but it is near to the value of 5, so we are taking the voltage source at 5, at almost at the middle of the wire. Then the option is 0, and the real part, which is 1. After taking the real part, the magnitude and the phase will put the value at their own, so you don't have to change them. Then the imaginary part is 0. Now we are in frequency section, or frequency. Here the 0100 and 0100 and 300. Here the 300, which is 300, is indicates the which indicates the frequency of the operating frequency. Now this is the design of a loaded dipole in free space. So we are run this simulation at free space. You can see the loaded dipole in the free space. They are giving you this parameter, which the antenna can radiate, or the antenna is designed to use for. Now you can see the far field pattern at 300 MHz frequency at full scale resolution at 5 degree. When you see this, the neck, the output of it, so there is an issue maybe happens. Now what happened in the frequency sweep when I try to design this parameter? Let's check it again. This is okay, and the radiation pattern, which is totally a circle, and you can see the 300 MHz frequency with the combination of rectangular and reflection coefficient, which is visible is 1.48132, and the reflection coefficient is minus 14.2545. They are saying the and here at last the last information, the frequency sweeping might be entered. No problem to fix separation in free space. At last information about the frequency and the sweeping must be entered, and no problem for a fixed frequency simulation at the 300 MHz and a dipole in free space. And their design parameter which indicates in the frequency section. Maybe there is an issue with the old and new edition. You can see there is the old edition simulation working with 4NEC2 editor. So in this, according to my precision, this is the latest edition software, so the parameters must be not match in free space, but free space for far field. But when we entered the frequencies, the radiation pattern comes, and we can see the radiation patterns at the view. You can see the radiation pattern and the gain, which is at 2.01 at 300 megahertz, and the impedance, which is 1.68831, which is the reactance of this design parameter, and the resistance is 73.9954. The magnitude of this value, and the angle r theta, which means the r theta form. Now we can visualize the vertical plane, which can see in the where we can see the radiation pattern and the geometry. Here you can see the line which is directed in the y-axis in positive and negative side. The antenna is designed in this pattern, and when we tap the 3D edition, we can see the antenna parameter, and if we want to see the segment, then you have to choose this option and put the segment to show this segmentation. You can see the radiation, the feed is in the center, almost in the center, and if you want to see the radiation pattern, then you have to set the middle option to multicolor. You can see the radiation pattern, which indicates the radiation of this antenna happens. So at the time of this designing parameter, you have to understand the value and the parameter of the radiation. So in the time of designing this software, we can change the parameter and see what happens in the other field output. You can see what happened at others. That means the design parameter does not run in other output window, which can generate in frequency sweep according to this. Then so it's sure to design this antenna parameter in this frequency sweep, but there is no indication because of the design is only for the radiation pattern in free space at 300 megahertz. Now we are trying to design this field. Wait, we can see the near field pattern. Is that indicates yes, it indicates the value. If you put the cursor at any point of this radiation pattern, then you can see the value of voltage per meter at the radiation, which is the violet or section. Then it means the maximum radiation happens here, and after this we can see the radiation pattern is already seeing. And when at the time of designing a dipole antenna over the ground, you have to understand that when we designing an antenna, to when we designing an antenna in the free space portion of dipole, then you have to put any of the value in axis in z direction. That means if we consider the xy axis as a 2D level, the 2D level indicates the length and width. So the z1 indicates the height. If we can assume the z1 or z indicates the height. So if we take any value of the positive direction of the height, then it can turns the antenna to the upward or downward direction of this z axis, which can be measured at a height. So if we put a value 0.5 meter, then you have to put this value 0.5 meter. It means the antenna is 0.5 meter over the ground, and it is not in over the ground, and it is not in the previous session. When we design this parameter and run this parameter, then the antenna should be goes up in z direction at 0.5 meter. So when we put this value, then we have to go to the frequency, and this must be in real ground. And put the check mark out and set this portion. By default it is in moderate mode, but you have to put this in average section. Then you have to run this parameter. When you run this parameter at far field section pattern, then you have to find this type of radiation pattern. If you press the upward and downward button, if you press the press button, then you have to find the radiation pattern and in horizontal plane, and you can find the vertical plane to pressing back to pressing the spacebar again. You can see the maximum gain is in 60 degree. Theta is equal to 60 degree, and the azimuth angle phi is equal to 0 degree. You can put the cursor at 60 degree. You can find there is maximum gain, which is 7.08 decibel. If you turn this rotate this in other side, then you can see at 60 degree minus 60 degree the gain is maximum, and the other range the total value is 0, and the cursor does not move to the negative portion of this z-axis, which means the antenna cannot radiate in the underground or ground level. It can radiate up on upper the ground level, and the maximum radiation pattern happens at 60 degree. So now we can design a frequency sweep, but before that you have to see in which angle the gain is maximum, which is 60 degree, and the phi is 0 degree. Then in the running section you have the frequency sweep, and you can set the frequency. My record frequency is 300 megahertz. Now I can take the lower limit as 250 and the upper limit is 351, and the theta is 60 degree, and the phi is 0 degree according to my far field pattern. Now we can generate and wait for the output. You can simulate, and finally giving the output, and the radiation pattern is look like this in vertical plane, and the ground plane is not, and the SWR of this pattern and the reflection coefficient at 300 megahertz look like this, and the gain, which is 7.06 at this frequency, and frequency back, frequency rear, which indicates the frequency back is the underground level of the frequency, and the upper level of the frequency of this antenna, which indicates at 300 megahertz is 0, and the rear is also 0, and the back is also 0, and the gain is 7.06. And you see the input impedance section. You can see the value which is at 300 megahertz, minus 7.6631, and the which is reactance, and the 70.2504, which is the resistance of this antenna, and this is the magnitude and phase form of which can be defined at r theta of this upper side value. So when we design this, and finally when we want to see the near field pattern, you can select this near field pattern and generate. Then the pattern showing look like this, which indicates the radiation from here to here. This is the almost middle of the radiation. You can see this scale here to design this parameter, and seen the radiation which indicates the violet, which indicates the maximum radiation. Red is less than that, the orange is less than that, yellow is less than previous. This means and finally when we put the value of 0, then the radiation is there is no radiation here, the dark deep blue, which indicates that there is no radiation pattern here. So you can see the radiation, and when you see this curve at this radiation this design parameter, you can see the antenna is now in upward of the ground at 0.5 meter up. So if you want to see the 3D radiation pattern, at first you have to run at frequency sweep and generate the output, and after getting the output you have to press the 3D button, and you can see it very clearly. And when you see that, you can see the segments. There is a segments of this antenna portion, and want to see the radiation in, you have to set the height pattern into multicolor, and you can see the radiation which is showing here at this both side of this antenna design. So in this area you can learn or understand the radiation at over the ground at any height, or at any height you can radiate. You can see the radiation pattern, the geometry, and showing the dipole over the over 0.5 meter ground, which is simulated real ground. Real ground means it does not situated or placed in real ground. It means when we put the checkbox is 0, it means the radiation impedance is not 0, which cannot which is I define that is the antenna is not in ground place, which is upper side of ground, but not situated in ground. So this is the part, and after that you have to save the file. Now to get the file and save as, which is I save dipole antenna over the ground, which is the 2. So after saving this, the file is saved, and that's for now. In this next parameter we have to so we are seeing the simulink in the radiation pattern in other direction. We are seeing this type of radiation almost here. So we are seeing the wire problem and thickness problem in the next part of this value. The value must be changed and the radiation pattern must be changed according to your getting value. When you put the value at the maximum level, when you put the value on the maximum level, and the radiation pattern must be depends on your thickness of wire or any other parameter that really affects your design. So this type of radiation which indicate this type of pattern, you can put the value according to them and you can get the value of their parameter. But don't worry about this design parameter which should be the same. It's not mandatory. The value of your assumption makes your radiation pattern different and makes the antenna in different level. So thank you. In the next video we are meet soon for the antenna thickness or antenna wire thickness problem at the editor window, and then there we can see the Smith chart or the optimization of the resonance. So thank you for this time. Goodbye.